Hello, good afternoon, all. Let's start our interview session on data science. Okay, before we go into any details, let's try to understand what is data science and what is the difference between data analytics and data science. Okay. So, answer is data analytics is also dealing with data, as well as data science also is dealing with data. But data analytics is the analysis or the study of data and trying to come to some insights or summary of the data and trying to give some insights about the data. Whereas data science, we will take the historical data, that is the past data, do the data analytics on it, and then we try to predict on future data. Our next question is, what are the stages of crisp DM and which stage is more important? Crisp DM has 6 stages: business understanding, data pre-processing, data modeling, data after modeling, we will do the model evaluation, and then we deploy. And the most important stage in CRISP DM as a data scientist is to do the data pre-processing. Data pre-processing. Now, for our next question, what are the Stages of analytics. There are 4 stages of analytics. The first one is the descriptive stage, where we will try to find out what is the problem. The second stage is diagnostic analysis, where we are trying to find what went wrong. And the third stage is predictive analytics, where we will be trying to predict the future. If we continue with the problem, what is the damage or effect of these problem in future? We'll try to calculate that. And the fourth stage is prescriptive analytics. That is, this is the stage where we will be planning the action. What are the different ways we can handle the problem, and then we come up with the best plan which works for the better business. Next question is, what is bias, variance, trade-off? Variance is also known as overfitting. Bias is known as underfitting. Variance is when we have the train accuracy high and test accuracy low. It is known as variance. Bias is when we have the train accuracy low and also test accuracy low. Variance or overfitting can be handled by regularization, whereas underfitting or bias can be handled by adding more data. Next question. What is scatter plot? Scatter plot is a bivariate graph. Bivariate means two columns are used to plot. We are trying to find the relationship between x and y variables. The scatter plot gives the direction between the two variables x and y, whether they are positively related or negatively related. It gives the strength between the two variables x and y, whether they are strongly related or weakly related or moderately related. And the other purpose of scatter plot is to find outliers as well as the clusters, if any. What is the difference between supervised and unsupervised models? Supervised learning is where we have input variables x and output variable y. Y output variable is dependent on input variables. So in this case, we can do the predictions. Coming to unsupervised learning, we don't have information about the output variable. So all the variables are treated as input variables. Here, as we cannot perform for two predictions, we are going to go with segmentation or grouping, also known as clusters. Here, we try to form groups depending on the similarities. There should be homogeneity between the elements of a cluster or a group, and then there should be heterogeneity between the different clusters or groups. What is p-value? P-value can help you determine the strength of your results. P-value is a number between 0 and 1. Based on the value, it will denote the strength of the results. The claim which is on trial is called the null hypothesis. Low p-value less than 0.05 indicates strength against the null hypothesis, which means we can reject the null hypothesis. High p-value greater than 0.05 indicate strength for the null hypothesis, which means we can accept the null hypothesis. And p-value equal to 0.05 indicates the hypothesis could go either way. High p-values means your data are likely with a true null. Low p-values means your data are unlikely with a true null. Okay, next question. How to combat overfitting and underfitting? To combat overfitting and underfitting, you can resample the data to establish the model accuracy, and by having a validation data set to evaluate the model. Our next question, what is regularization and why is it useful? Regularization is a process of adding tuning parameters to a model to induce smoothness in order to prevent overfitting. This is most often done by adding a constant multiple to an existing weight vector. This constant is often the L1 lasso or L2 rich. The model prediction should then minimize the loss function calculated on the regularized training set. Our next question, what are the types of biases that can occur during sampling? Selection bias, undercoverage bias, and survivorship bias. What is survivor survivorship bias? Survivorship analysis, survivorship bias. We are talking about the biases, and survivorship bias is the logical error of focusing aspects that support surviving some process and casually overlooking those that did not work because of their lack of prominence. This can lead to wrong conclusions in numerous different means. Okay, now that we are looking into the biases, let's look into selection bias. Selection bias occurs when the sample obtained is not representative of the population intended to be analyzed. In this kind of bias, we are making a mistake or error while selecting the sample. Now let's talk a little bit about the different tools we use for data analysis. Python or R. Which one would you prefer for text analytics? Okay, we prefer Python because of the following reasons. Python would be the best option because it has pandas library that provides easy to use data structures and high performance data analysis tools. R is more suitable for machine learning than just text analysis. Python performs faster for all types of text analytics. Next, let us talk a little bit about data cleaning. Okay, what is the role of data cleaning? Data cleaning can help in analysis in different ways. Cleaning data from multiple sources help to transform it into a format that data analytics can work with. Data cleaning helps to increase the accuracy of the model in machine learning. It takes up to 80% of the time to prepare the data. Differences between univariate, bivariate, and multivariate analysis. Univariate analysis are descriptive statistical analysis techniques which can be differentiated based on the number of variables involved at a given point of time. The bivariate analysis attempts to understand the difference between two variables at a time, as in a scatter plot. Multivariate analysis deals with the study of more than two variables to understand the effect of variables on the responses. What is cluster sampling? Cluster sampling is a technique used when it becomes difficult to study the target population spread across a wide area and simple random sampling cannot be applied. Cluster sample is a probability sample where each sampling unit is a collection or cluster of elements. What is systematic sampling? Systematic sampling is a statistical technique where elements are selected from an ordered sampling frame. In systematic sampling, the list is progressed in a circular manner. So once you reach the end of the list, it is progressed from the top again. The best example of systematic sampling is equal probability method. What are eigenvectors and eigenvalues? Eigenvectors are used for understanding linear transformations. In data analysis, we usually calculate the eigenvectors for a correlation or covariance matrix. Eigenvectors are the directions along which a particular linear transformation acts by flipping, compressing, or stretching. Now, for eigenvalue, eigenvalue can be referred to as the strength of the transformation in the direction of eigenvector or the factor by which the compression occurs. Now, what is the difference between validation set and test set? A validation set can be considered as a part of the training set as it is used for parameter selection and to avoid overfitting of the model being built. On the other hand, a test set is used for testing or evaluating the performance of a trained machine learning model. Explain cross-validation. Cross-validation is a model validation technique for evaluating how the outcomes of a statistical analysis will generalize to an independent data set, mainly used in backgrounds where the objective is forecast and one wants to estimate how accurately a model will accomplish in practice. The goal of cross-validation is to term a data set to test the model in the training phase in order to limit problems like overfitting and get an insight on how the model will generalize to an independent data set. Now, what are various classification algorithms. We have linear decision trees, SVM, neural networks, quadratic, and kernel estimation under this classification algorithms. What is knife in, knife base? The knife Bayes algorithm is based on the Bayes theorem. Bayes theorem describes the probability of an event based on the prior knowledge of conditions that might be related to the event. The algorithm is naive because it makes assumptions that may or may not turn out to be correct. Explain SVM. SVM stands for support vector machine. It is a supervised machine learning algorithm which can be used for both regression as well as classification. If you have n features in your training dataset, SVM tries to plot it in n-dimensional space with the value of each feature being the value of a particular coordinate. SVM uses hyperplanes to separate out different classes based on the provided kernel function. What are different kernels in SVM? The different kernels in SVM are linear kernel, polynomial kernel, radial basis kernel, and sigmoid kernel. Explain. Decision tree. A decision tree is a supervised machine learning algorithm mainly used for regression and classification. It breaks down the dataset into smaller and smaller subsets, while at the same time, an associated decision tree is incrementally developed. The final result is a tree with decision nodes and leaf nodes. A decision tree can handle both categorical and numerical data. What is pruning in decision tree? Pruning is a technique in machine learning and search algorithm that reduces the size of decision tree by removing sections of the trees that provide little power to classify instances. So when we remove subnodes of a decision node, this process is called pruning or opposite process of splitting. What is logistic regression? Logistic regression, often referred to as the logit model, is a technique to predict the binary outcome of a linear combination of predicted variables. What is linear regression? Linear regression is a statistical technique where the score of a variable y is predicted from the score of the second variable x. X is referred to as a predictor variable and y as the criterion variable. What are the drawbacks of linear model? The drawbacks are the assumption of linearity of the errors. It can't be used for count outcomes or binary outcomes. There are overfitting problems that it cannot solve. What is the difference between regression and classification techniques? Both regression and classification machine learning techniques come under supervised machine learning algorithms. In supervised machine learning algorithms, we have to train the model using labeled data set. While training, we have to explicitly provide the correct labels, and algorithm tries to learn the pattern from input to output. If our labels are discrete values, then it will be a classification problem. But if our labels are continuous values, then it will be a regression problem. What are recommender systems? Recommender systems are a subclass of information filtering systems that are meant to predict the preferences or ratings that a user would give to a product. Recommender systems are widely used in movies, news, research articles, product, social tags, music, etc. How can outlier values be treated? Outlier values can be identified by using univariate or any other graphical analysis method. If the number of outlier values is few, then we can access individually, but for a large number of outliers, the values can be substituted with either 99th or the first percentile values. All extreme values are not outliers. The most common ways to treat outlier values is to change the value and bring it within a range. And the next way or the alternate way is to just remove the values. Bringing the values within a range is known as venturization. And removing the values is known as trimming. How to treat missing values. The extent of the missing values is identified after identifying the variables with missing values. If any patterns are identified, the analyst has to concentrate on them as it could lead to the interesting and missingfulness business insights. If there are no patterns identified, then the missing values can be substituted with mean or median values, or they can simply be ignored. Assigning a default value, which can be mean, minimum, or maximum value, getting into the data is important. If it is a categorical variable, the default value is assigned. The missing value is assigned a default value. If you have a distribution of data coming for normal distribution, give the mean value. If 80% of the values for a variable are missing, then you can answer that you would be dropping the variable instead of treating the missing values. What is ensemble learning? Ensemble learning is basically combining a diverse set of learners together to improvise on a stability and predictive power of the model. What are different ensemble techniques? Let's talk about bagging. Bagging tries to implement similar learners on small sample population and then take a mean of all the predictions. In generalized bagging, you can use different learners on different populations. Let's talk about boosting. Boosting is an iterative technique which adjusts the weight of an observation based on the last classification. If an observation was classified incorrectly, it tries to increase the weight of this observation and vice versa. Boosting in general decreases the bias error and builds strong predictive models. Problem is they may overfit on the training data. What is random forest? Random forest is a versatile machine learning method capable of performing both regression and classification tasks. It is also used for dimensionality reduction, treats missing values, outlier values. It is a type of ensemble learning method where a group of weak models combine to form a powerful model. How do you work towards random forest? The underlying principle of this technique is that several weak learners combine to provide a keen learner. The steps involved are build several decision trees on bootstrap training sample of data. On each tree, Each time a split is considered, a random sample of predictors is chosen as split candidates out of all PP predictors. Predictions at the majority rule. Okay, we will stop our session here. Thank you. Next time, meet you all with more questions.